Welcome back. Today, we are diving into something truly powerful, the journey of a river. We're going to trace how it goes from just a tiny little stream to a massive force that can literally carve up entire landscapes. It's pretty incredible when you think about it. And really, it all boils down to this one simple question, right? How does something as basic as water manage to carve solid stone? I mean, it's a process that has shaped our entire planet for millennia. So yeah, how does it all work? Let's get into it. So here's our game plan for today. We're going to start with the river's toolkit, what it actually uses to do all its work. Then we'll follow its life story, from its powerful youth through its wandering middle age and into its building phase in old age. And to wrap it all up, we'll look at how we as humans live with these incredible forces of nature. All right, so before we jump on that journey downstream, we've got to understand the basics. Let's look at the two fundamental tools a river uses to get the job done. Erosion, its cutting force, and transportation, its carrying force. Okay, first up is erosion. This is basically the river's cutting power. You can think of it like a sculptor's chisel, just, made of water. And it's constantly carving away at the land, breaking down solid rock and soil. And what's really cool is that erosion isn't just one thing. A river has this whole toolkit with 4 different methods. You've got hydraulic action, which is just the sheer brute force of water slamming into the riverbanks in bed. Then there's abrasion, where the river uses rocks it's already carrying, like sandpaper, grinding away at the landscape. Attrition is when those rocks in the water smash into each other, breaking down into smaller, rounder pieces. And finally, solution. This one's a bit more subtle. It's when the river water actually dissolves certain types of rock, like chalk. Pretty neat, huh? But breaking all that rock apart is only half the battle, right? The river can't just leave all that rubble lying around. It has to move it. That material is called the river's load, and moving it is the job of its second major tool, transportation. And again, just like with erosion, there are 4 different ways a river moves its stuff. For the really big stuff, the giant boulders, that's traction. They just get rolled along the bottom. For smaller pebbles and stones, you get saltation. It's like they're bouncing or skipping along the riverbed. Then there's suspension. This is all the really fine, light material that's just held up and carried along within the water itself. It's what makes rivers look muddy. And finally, you have solution again, this time carrying those dissolved minerals downstream, totally invisible. Okay, so we've got our toolkit. Now, let's actually start the journey. We're heading way up into the mountains to the upper course. This is where the river is young, fast, and just full of raw, untamed energy. So way up here, the land is super steep. That steepness, that gradient, gives the river a ton of energy. And all of that energy is focused straight down. The river isn't trying to get wider here, it's like a drill, just relentlessly cutting vertically into the earth. And that's what carves out those iconic, deep, narrow, V-shaped valleys. And of course, the upper course is home to probably the most dramatic river feature of all, the waterfall. It all starts when a river flows over a layer of really tough rock that's sitting on top of a much softer rock. Naturally, the soft rock gets worn away faster, creating a step. Water pours over that step, smashing down and carving out a deep hole called a plunge pool. This undercuts the hard rock above until, eventually, it collapses. The waterfall has now moved back a bit. This whole process just repeats for thousands of years, with the waterfall retreating upstream and leaving a stunning gorge in its wake. All right, so our river is growing up. It's leaving the steep mountains behind and entering its middle course. Think of this as its middle age. The land flattens out, the pace slows down a bit, and its journey starts to, wander. The big change here is the direction of its energy. In the upper course, it was all about eroding downwards. Now, in the middle course, it starts eroding sideways. This is called lateral erosion. So instead of drilling down, it starts to swing from side to side, creating these big, wide, sweeping bends that we all know as meanders. And this sideways action leads to one of the coolest features in all of geography. See, on the outside of a meander, the water flows faster and erodes the bank. On the inside, it's slower, so it drops material. This makes the bend get bigger and more loopy. The neck of land between the bends gets narrower and narrower until, boom! During a big flood, the river punches right through, taking the shorter path. Over time, sediment seals off the old loop, and what you're left with is this beautiful crescent-shaped oxbow lake. Okay, we're reaching the final stage of our journey, the lower course. The river is in its old age now. It's wide, it's slow, and the land is super flat.
and its main job is no longer cutting or wandering. Now it's a builder.
So, the river has been carrying this massive load of sediment all the way from the mountains. But down here, it's moving so slowly, it just doesn't have the energy to hold on to it anymore. So it starts to drop it. And every time the river floods, it deposits this material, building up these huge, flat, and really fertile areas called floodplains. And one of the coolest things it builds is something called a levee. Here's how it works. When the river floods, it drops the heaviest material first, right next to its banks. With every single flood, another layer gets added, and over time, these natural embankments build up, acting as a sort of natural flood defense. Now, obviously, that same power that builds up new land can also be pretty destructive. Flooding is a huge risk. And that brings us to the human side of the story, how we try to manage our relationship with these powerful forces.
Generally, we approach this in two different ways. On one hand, you have hard engineering. This is the big, intrusive stuff, building concrete walls, straightening channels, dredging the river deeper. On the other hand, you have soft engineering. This is about working with the river, things like planting trees to absorb water or intentionally allowing certain areas to flood where it won't cause damage. It's often cheaper and more sustainable.
And if you want to see why managing rivers is so incredibly important, look no further than Boscastle in Cornwall back in 2004. In just 2 hours, an incredible 1.4 billion liters of water fell. I mean, can you even picture that? It was a wall of water that completely overwhelms the local rivers. The aftermath was, as you can imagine, devastating. It prompted a huge flood defense project that cost £4.6 million to make sure something like that wouldn't happen again. And what they did in Boscastle is a great example of using a mix of strategies. They did some hard engineering, for sure. They made the river channel wider and deeper, but they also did some smart, soft engineering. They used something called floodplain zoning, which basically means they moved the town's car park to a safer spot. It really shows you the complex challenge of living alongside these powerful natural systems. So, that brings us to the big final question, doesn't it? As our world changes, as our climate changes, rainfall patterns are getting more extreme. The story of our rivers isn't over. In fact, it's being rewritten right now. And how we decide to change our relationship with them, well, that's going to define our future landscape.